Question 52. So you're given a rational function, so here's its equation, and you also get a sketch of its graph. X plus 2 over x minus 3. Okay, so you get its graph as well, I won't sketch that. You are being asked where do the asymptotes of this function intersect. So we have a vertical asymptote at x equals 3. So vertical asymptotes come from restrictions on the denominator. Wherever the denominator, whatever makes this expression in the denominator 0, that's a value that's excluded from the domain, and hence it's a vertical asymptote. So, okay, this graph also has a slant or oblique asymptote, and that happens because if we just expand this, so we get 2x squared plus 4x, we see that the numerator is 1 degree higher than the denominator, and that gives us the condition for the slant asymptote. The way that we find that is to do a bit of polynomial long division. So we need to re-express this function as a linear function. So if you don't know how to do polynomial long division, I'll be putting up a video on that sooner or later. For now, I just suggest you look it up somewhere else. So I'm going to do this one quite quickly. So x is into 2x squared, go 2x, multiply that back down, 2x squared minus 6x. Subtract, that's 4x minus 6x is plus 10x. X is into 10x, go 10 times, bring down this 0 here. Multiply this back, 10x minus 30. Okay, so then when we subtract this, we get plus 30. So that means yet another way to express this function is the linear part that we found, 2x plus 10, plus 30 that we still have to divide by x minus 3. Okay, just separating those a bit. So the equation of our slant asymptote is the linear part that you found from polynomial long division, i.e. the equation y equals 2x plus 10. We're being asked for the point of intersection of these. As a kind of strategy hint, if you can't find the slant asymptote or you forget how to do it, some of the answer choices you can cross out. You can cross out f and g because they don't have an x-coordinate of 3. So you know that immediately, even if you can't find the slant asymptote, so that narrows down your guessing choices to a 1 in 3 chance. Assuming you can find the slant asymptote, this is how to see where they intersect. Just plug in the x-coordinate of the vertical asymptote into the equation. So 2 times 3 plus 10 is 16. So our point of intersection is 3, 16, making answer choice J correct here.